Hello everyone. In the previous lectures, we have discussed about what is meant by artificial intelligence, machine learning, deep learning, what are the different machine learning tasks and applications, how to define a machine learning problem, and how to design a machine learning system. In this lecture, we are going to discuss about spam email detection, which is one of the machine learning applications. Myself, Dr. GNVG Sirisha, working as Assistant Professor in the Department of Computer Science and Engineering in SRKR Engineering College. The objectives of today's lecture are to understand the differences between developing spam email detection system using traditional methods like using regular expressions and using machine learning. What is the role of machine learning in developing spam email detection system? And how to use different models like linear classifier, Bayesian classifier and rule-based classifier in detecting spam emails. Spam email detection system. Earlier, prior to machine learning, hand-coded pattern matching techniques such as regular expressions were used to classify an email as spam or ham. This approach is hard to maintain and offers insufficient flexibility. One person's spam email may be another person's ham email. For example, if I am shopaholic, emails containing information like ads of new clothes, shoes, jewelry, furniture, etc. will be ham to me. But the same emails may be spam to some other person. So spam email detection systems based on hard-coded rules will not be able to adapt to different persons' needs. Spam Assassin is a widely used open source spam filter. It tags an email as a junk or spam email if the score calculated by Spam Assassin is above 5. This is done by doing a number of tests and aggregating the scores of all the tests. We can see Spam Assassin by Apache here. For example, what are the tests that the Spam Assassin does? Here are some of the examples of the tests the Spam Assassin does. First one is image to text ratio. Second is whether the email contains the body or not. Third one is what is the font used in the email. Spam Assassin simply aggregates the scores of all the tests, and if the aggregated score is above or equal to 5, the email is marked as spam. Spam Assassin gives the same importance or weight to all the tests. But is it correct to give the same importance or weight to all the tests? Suppose we want to give different weights to different tests. How do we know what are the weights we need to assign to each test? So here comes the role of machine learning. So here we can see a table of 4 emails and there are 2 tests x1 and x2. This is sample training data. X1 represents a test like whether the email contains a word lottery. Second, X2 represents another test asking whether the email contains the word free iPod. In the training data, we can see there are 4 emails. In the first email, both the words lottery and free iPod has appeared and it is labeled as spam. The second email neither contains free iPod nor lottery. It is ham. Third email contains the word lottery but not free iPod and it's also a ham email. The fourth email contains the word free iPod but not lottery and it is also ham. The last column in this data indicates the scores that are calculated for all these 4 emails by Spam Assassin. Here the threshold is 5. So if the score assigned to any email is greater than 5, it will be labeled as spam. If the score calculated is less than or equal to 5, the email will be classified as ham. So based on this data, now we need to learn the weights to these two tests x1 and x2. From this data, we can see that the weights that are assigned to x1 and x2 can be anything between 2.5 and 5. So it should be greater than 2.5 and less than 5. So if there are n tests, then the spam assassin can be mathematically represented as sigma I is equal to 1 to n wixi greater than t, where n is the number of tests or the features. Xi represents the outcome of ith test. So xi is a boolean variable which can have a value of 1 or 0. Wi is the weight assigned to ith test. T is the threshold function, threshold value. So if the sum of Wixi is greater than T, the email will be tagged as spam or else it will be tagged as ham. So here we can see spam assassin's approach to spam email classification task. The text of each email is converted into data points by means of spam assassin built-in tests. Now a linear classifier is applied to obtain the spam or ham decision. The linear classifier is defined by this equation sigma I is equal to 1 to n wixi greater than t. The linear classifier is identified by this decision boundary. Linear classifiers can only classify linearly separable classes. Here we can see the role of machine learning in this spam filtering. Spam assassin conducts the test on the email and it returns the results of the test. So for every email, it specifies whether each test is successful or not. The output of spam assassin is taken as data. So using this data, and for this problem, we apply a machine learning algorithm which will learn weights for each of these tests. So the output of this machine learning algorithm is a model called linear classifier. The linear classifier is defined by the equation sigma I is equal to 1 to n wixi greater than t. This model can be used in future to classify whether any new email is spam or not. So the role of machine learning here is to learn the weights that are to be assigned to the different tests. So we have discussed about one way of learning the weights for different tests, and we have seen how to build a linear classifier which can be used for spam email detection. Apart from linear classifier, we can make use of other models like Bayesian classifier, rule-based classifier, etc. Bayesian classifier is a probabilistic classifier which makes the classification based on the content of email. Rule-based classifier is a classifier which treats each email on a case-by-case basis. In the Bayesian classifier, the decision rule can be written as pi I is equal to 0 to n oi greater than 1, where n is the number of tests. Each test is represented as x0, x1, x2 and so on, xn. Oi represents the prior odd of test xi. Oi is given as probability of spam given xi by probability of ham given xi. O0 is probability of spam emails by probability of ham emails in the training data. Next comes rule-based classifier. Rule-based classifier builds logical conditions that identifies subsets of data that are sufficiently similar to be labeled in a particular way. It makes use of a set of rules for classification. So this is the overview of how machine learning is used to address a given machine learning task. Previously, we have seen a similar diagram here where a linear classifier is learned from the data, training data. So here, this is the generalization of the diagram where the different machine learning algorithms can be used to learn the models from the training data. So the model is the output of machine learning algorithm. Then, as we have already seen, there are different ways of building a machine learning system for a given problem. For the spam email detection, we have seen three different types of classifiers: linear classifier, probabilistic classifier, and the rule-based classifier. Linear classifier uses hard-coded features in order to learn the weights, whereas Bayesian classifiers uses the entire content of the email for classification purpose. When we have multiple solutions to a given machine learning problem, which solution do we need to choose? We should always choose a solution which does not overfit the data. For example, what is meant by overfitting? Suppose there are a class of students who need to write an exam, end semester exam. So the students start preparing for the exam. So they refer to all the old question papers of a particular subject. They solve all the old question papers and thoroughly prepare all those papers in order to get a good score in the exam. In the exam, a completely new set of questions from the same syllabus have appeared. So then the performance of the students will be poor. So that is what is called as overfitting. A model which performs very well on the training data, but whose performance is poor on the new data is said to be overfitted model. So we have to avoid such models. We should always prefer models which has good generalization capacity. In this lecture, we have discussed about Spam Assassin, which is a tool for classifying emails as spam or ham. Earlier, Spam Assassin treated all the tests or features equally importantly in identifying whether an email is spam or ham. But generally, some features or some tests have more importance in predicting whether an email is spam or ham. So it means we have to assign different weights to different features or tests. So assigning different weights and learning those weights can be done by using machine learning. So we have seen three different ways of classifying emails as spam or ham using machine learning. The first one is by making use of the linear classifier, which is defined by an equation sigma I is equal to 1 to n wixi greater than t, where xi represents a test whose value is a boolean value either 0 or 1. Wi is the weight assigned to the test. T is the threshold above which emails are classified as spam. The second classifier is Bayesian classifier, which is based on the decision rule pi I is equal to 0 to n oi greater than 1, where oi represents the prior odd of test xi. The last one is rule-based classifier, which is built based on logical conditions that identify subsets of data that are sufficiently similar to be labeled in a particular way. Thank you.